This is a recording for topic 7-1, rates of change. Today's objective is I can determine the slope of a line from a graph and a table. So our essential question will be, how can I determine the slope of a line from a graph and a table? When we finish the lesson, we should be able to answer this question. Our bell work problem for today is a sales tax rate at a clothing store is 8.75%. The sales tax on an item is a function of its price. Which of the following is the dependent quantity of this function? If I know the sales tax on an item is a function of this price, recall, is a function of is another way of saying depends on. And then what comes in front of that is our dependent. And what comes after it is our independent. We've talked previously, D comes before I in the alphabet. So our dependent comes before our independent when it's stated in a sentence using is a function of or depends on. So which of the following is our dependent quantity? We want to look for sales tax on an item. A says sales tax rate on an item. The key here is that it says rate. Our dependent should just be sales tax, not a rate. So A is not it. B is the item's price. Again, according to our sentence, the dependent is the sales tax on an item. That is not the item's price. C says the amount of sales tax on the item. That matches what states in our sentence, but let's check the last one to be sure. D says the item's size. We have nothing in our sentence that mentions size. So D is not it. The correct answer is C. Today we're going to talk about rates of change. We have our nice little visual where the output is equal to the change times the input plus how it starts or how it begins. So the way we look at this, our output is our Y. Our rate of change, that's the change. Our input is our X. And then how it starts is where we begin, what we've been calling B. Our rate of change is also known as the slope. The slope measures the steepness of a line. Oops. Steepness tells you like how far it's going to rise, whether it's really steep or not so steep or even just a flat line. So slope is also the constant rate of change. That's how that line changes over a period of time. So when we look at the slope, we're looking at the change in your Y values over the change in your X values. Sometimes we write this as a triangle, which means delta. Delta Y means the change in Y. And a change in X, sometimes we write it as a delta X. Since our Y-axis goes up and down, our change in Y tells us how far we're going to rise. The X-axis goes left and right, so the bottom number, tells you how far we're going to run. Imagine if I asked you to walk out the door. You're sitting in a room. I want you to walk out the door. The first thing you would have to do is to stand up or rise before you can walk out the door. The walking out the door part is the run. So you must rise first, up and down, before you can walk. Let's apply this to some problems. For example 1, we are given a table. First thing we're going to do is to actually draw a graph based upon the table. We're given X coordinates and Y coordinates in a table. If I want to write them as an ordered pair, this first coordinate would be a -2, 9. So our X-axis is the one that goes left and right. Y-axis goes up and down. -2, I go -2 on the X-axis, and then I go up 9 on the Y-axis, and I have my point at -2, 9. My next point is at negative 1, 4. So x-axis negative 1, y-axis a positive 4. 0, negative 1, x-axis is 0, y-axis is negative 1. I have 1, negative 6, x-axis is 1, y-axis is negative 6. And 2, negative 11 would be off our chart. Using your ID as a straight edge, or if you have a straight edge that you can use, we're going to connect the dots and draw a line. Drawing a line connecting your dots, you want it as best as possible, going through all the points. When you put your dots on the graph, make sure you put all of them. The other thing with our line, it needs to have arrows at the beginning and at the end, showing that the line goes on forever and ever. It doesn't have a stop or a starting point. So I have our line. Now I'm going to skip the rate of change in the beginning and go down to, does the graph increase or decrease? The way that we tell that is we read the graph left to right as if we were reading a sentence. So when I'm reading my graph left to right, I want to start at the leftmost point, which is the one up above. As I follow this line, I notice that I am going down as I go along the line. So because I'm going down, that means that this graph is decreasing. That also tells me that my rate of change, or how the line is changing, it is changing in a negative direction because it's going down. So my rate of change is negative. The way that I determine how it's changing, I need to know, how is it changing along the y, and then put that over how it changes along the x. So from how is it rising and running. So let's start. Pick any 2 points on your graph. I'm going to pick, one of the points that I will pick will be the y-intercept, where it crosses the y-axis. So here's one. The other point that I'm going to choose can be any other point. I'm going to choose the one to its right. Now, in order to figure out how much it changes, I'm going to connect those points by drawing a little triangle. Let's try that again. So drawing a triangle. One point to the other. I need to figure out how far do I go up and down in order to reach the next point. So I'm figuring out how far I go up and down. I'm going to count how far I go up. That's 1, 2, 3, 4, 5. I had to change by 5 in the y direction. In the x direction, I had to change by 1. So my rate of change is negative 5 over 1. I could also do this on the table. If I pick any 2 points on the table, I'm going to pick the negative 1, 4, and also 0 to negative 1. Those 2 points, I'm going to look, how does my y change? In order to go from a positive 4 to a negative 1, I would have to subtract 5. In order to go from a negative 1 to a positive 0, I would have to add 1. So the negative 5 tells me how far I went down. The positive 1 tells me how far I went to the right. So our rate of change is negative 5. Our beginning is where it crosses the y-axis. Remember that your beginning is your y-intercept. My y-intercept, my x-coordinate is always 0, and where it touches the y-axis is at negative 1. So our beginning is at 0, negative 1. That tells me my b equals the negative 1. So my equation, my output is the y. It changed. We have our change. It changes by negative 5 over 1. My input is the x, and we began at a negative 1. Instead of writing the change as a fraction, you could just have negative 5 and then x minus 1. So from our graph, we were able to determine our rate of change and also our beginning. Example number 2. This time we're actually given an equation, and now we need to fill in our graph as well as, fill in our table as well as our graph. We are given an equation y equals 2x plus 3. Anytime you are given an equation with y equals, you should ask yourself, can I use this in my calculator? Because my calculator has a y equals button. So we're going to use the calculator, turn it on. We'll go to y equals. I have something there. Let me clear it out. We're going to type in what's on the right-hand side, 2x plus 3. To get to the table, because that's what we want, we're going to hit tab second and then graph to get to the table. From that table, now we can fill in our chart. When x is negative 2, our y is negative 1. When x is negative 1, our y is a positive 1. When x is 0, y is 3. When x is 1, y is 5. And when x is 2, y is 7. Now we're going to plot our points. When x is negative 2, y is negative 1. At a point, x is negative 1, y is 1. When x is 0, y is 3. When x is 1, y is 5. And when x is 2, y is 7. Using a straight edge, I can connect my dots. As you can see, I didn't use a straight edge, but I do expect you to. Our rate of change, we're going to pick any two dots. Again, I like to start with our y-intercept, and then any other 2 points. This time I'm going to go to the 2, 7, just to show you it can be used any 2 points. I'm going to draw a triangle to connect those dots. Now I'm going to count how far did it change going up and down. 1, 2, 3, 4. It changed going up 4. To go to the right, I went 1, 2 to the right, so 4 over 2. I also notice that my graph is increasing, or it's going in a positive. Again, if I read it left to right, I go to the leftmost point, and now as I follow my line, I am going up. That means it is increasing. That means our rate of change is positive. 4 divided by 2 is 2. So my rate of change is 2, or 2 over 1. My beginning, I started off on the y-axis, so I'll start on the y-axis to find out where does my line touch? It is touching at 0, 3. So my beginning, the b, is a positive 3. I can also pick this out from my table. Wherever x equals 0, that's going to be my beginning. I'll do a little check. To go from 3 to 5, I have to add 2. To go from 0 to 1, I have to add 1. So 2 over 1 does give me a rate of change of 2. I could have also picked this out from my equation, because notice my rate of change is the 2. My beginning is the 3. So it all checks out. Here we go. Our last problem, or example 3. This time we're giving points. We need to come up with our table and our equation. So with our points, let's go ahead and connect those dots. Using a straight edge, you want to get all of them connected as well as you can. Going through the exact points themselves. Again, make sure you put the arrows on the end, showing that you do have a line. Now we'll fill in the table as far as we know. We know that at 1, x is negative 1. At 0, x is negative 4. And at -1, x is at -7. I can look at my graph and see, starting at the leftmost point, and I read my graph, I'm going up, so I am increasing, which means the rate of change is going to be positive. If I choose any 2 points, I'll start with the y-intercept, and I'll choose one to the right, draw my little triangle. It's going to change going up and down by 1, 2, 3, and I had to move left or right just 1. So my rate of change is 3 over 1. The beginning point is at 0, -4. Can get that from my table or from the graph. This tells me the b is equal to -4. Therefore, my equation, output is y equals 2. It changes by 3 over 1. Input is x, and I started off at a -4. To fill in the rest of the table, I can either use my graph at -2. The y value is a -9. At +2, the y value is a +2. Or I can check myself by turning on the calculator. I now have an equation. We'll type the equation in. 3x minus 4, hit second table. So at -2, and I'm glad I did that, I should be at -10, not -9. -1 is -7, 0 is -4, 1 is -1, and 2 is 2. Now we do our summary. Should have a summary in here. Our question was, how can I determine the slope of a line from a graph in a table? So the way that we determine the slope of a line, let me see if I can get an extra page in here. Hold on. So our essential question was, how can I determine the slope of a line from a graph or a table? So from a graph or a table, I can determine the slope by determining the change in y over the change in x. Or I look at the rise and run between 2 points. So if I have 2 points, I can figure out what the change in y is over the change in x. And that is how we will determine the slope given a graph or a table. This concludes topic 7-1, rates of change.